Hello everyone, welcome back to this video series on clinical SAS programming. So we are taking a look at the how I solved it videos. So in this video, we will see where I had to identify the last dosing date before an adverse event start date. So let us go to the specification. So it says the requirement is simple, find the last date prior to the start of an adverse event start date. So we have ADAE as input and exposure dataset as input for this task. So let me open the data here on the left hand side as well. So I have my AE data here on the left hand side and I have my exposure data here on the right hand side. So we know that in exposure we will have one record per constant dosing interval. So we have dosing for subject 1001 and 1003 and the start date and end date of each of the intervals are provided here. And on the left hand side we have our ADAE dataset. We have multiple adverse events experienced by the subjects and we have the start date of those events. So there is an event on 1st Jan 2023, 15th Jan, 2nd Feb, 15th Feb and 5th March 2023 for subject 1003, and these are the exposure date. So when we have a record in exposure with the start date of 1st Jan 2023 and the end date of 10th Jan 2023, which means the subject received a dose on 1st, 2nd, 3rd and all the way till 10th Jan. So there could be an event start date, and this event start date uh, we'll have to identify the exact dosing date prior to this event start date. So here we have the dates collected in interval. So the event could have started somewhere in between these two dates. So if it started somewhere in between these two dates, so we'll have to find the day of dosing prior to that start of the adverse event. So here if we see for first subject, first event, which happened on 1st Jan 2023. So here, if we take a look at the example, so the dosing itself started on 1st Jan 2023 and it ended on 2nd of 10th Jan 2023 here. So we are looking for the last dosing date before an adverse event start date. So as it happened on the same date, there is no record before this date. So we'll have the last dosing date prior to 1st Jan event, we'll have it as missing. So if we take the example for 15th Jan event, so let us see whether when did the subject take the last dose before the 15th Jan 2023. So here we have the second record which started on 11th Jan and ended on 13th Jan, and then the third record which started on 15th Jan and ended on 18th Jan. So the last dose received prior to 15th Jan 2023 is 13th Jan. So we'll have to populate it with that value here. And for 2nd Feb 2023, let us see what is the record we have in terms of Feb for that subject. So 1001 and the latest date before 2nd Feb. So here if we see, so 28th Jan, the event exposure ended and started again on 1st Feb, which means so before 1st Feb, the last dosing date was 28th Jan. So we should populate it with that value here of 28th Jan on the record with an event start date of 2nd Feb. So here is the final dataset that we are creating. So here if we see the before, sorry, the date was 2nd Feb was the event start date. So it should be 1st Feb. So we'll have to populate it with that value. And then there is an event on 15th Feb and the last dosing date from this data is only till 13th Feb. So we'll have to populate it with the value of 13th Feb here. So this is the final output data set that we are going to derive. So we'll see how that can be programmed. So let me go back to the program. So here I have my program that is used to identify the last dosing date prior to an adverse event start. So I am expanding my exposure dataset to have one record per each date value reported in this interval. So here we know that when the start date is 1st Jan and end date is 10th Jan, it means that the subject took a dose on 1st, 2nd, 3rd, and all the way till 10th. So I am expanding this record from start date to end date and creating a new variable called date with the each individual date value. So I am creating a new numeric variable called start dt by using exstdtc by converting that value to numeric. And similarly, I am creating numeric variable for exendtc and naming it as enddt. And then I am using a do loop with the counter variable name as date, starting it from the value present in start dt variable and ending it on the value present in end dt variable. So, and then outputting a record for each of the instance of the loop. So here for this, so there are 10 date values possible. So when this loop gets executed, so this record gets outputted 10 times, each time with the value in date variable picking from the value of exstdtc of 1st gen, 2nd gen, 3rd gen, and so on for those number of instances. And then let us take a look at ex01 and see how this gets structured. So here we see there was one record from 1st Jan 2010 to 10th Jan 1st Jan 2023 to 10th Jan 2023. So we have expanded it 10 times and the date value on each of those records correspond to the each individual date lying in between exstdtc and exendtc. Similarly, we are doing it for all the other records. So the entire dataset gets expanded to have each individual date value created. And then we are trying to compare our adverse event start date with the individual exposure date. So here if we see, we are making use of SQL join. So we are fetching all the variables from A dataset, which is identified. A is used for identifying the dataset ADAE, and we are using B to identify the records or the variables coming from EX01 dataset. So we are selecting all the values, all the variables from ADAE, and we are fetching date variable from EX01 and creating a new dataset called ADAE02. And we are joining ADAE with exposure using left join operator, and then we are joining it on the matched records between the subject ID of ADAE and EX01. And then in the join condition, we are filtering only those records where the date value is less than the adverse event start date. So by default, SQL does a Cartesian product, which means it will try to create uh, a Cartesian product, which means if for the subject 1001, if we see, we have 4 records here. And let's take a look at EX01 here. So for subject 1001, how many records do we have? So we have 44 records here. So it will create 44 records for this first record and 44 records for this second record and additional 44 records for the third record and additional 44 records for this fourth record. So that's how Cartesian product at subject level will work for. And then in that, along with that additional condition of specifying or matching on use of JD, we are also asking after the join, we are trying it to filter for only those records where the date is less than the adverse event start date on any particular record here on the ADA. So let us take a look at ADA02 and then see how it looks like. So here if we see, so if we take a look at ADAE, we have 5 records, but if we take a look at ADAE02, we have many records available here. So let us try to filter for subject 1001 and then for event 1. So here if we see, there was only one record in our ADAE, but we have multiple records here. Why are we getting these multiple records with this join condition is we have joined our ADAE with EX01 at subject level, and then we are filtering only those records where date is less than ASTDT. So here if we see, so these are the different exposure dates from our EX01. So we have cross-checked what we have fetched all the date values, exposure date values which occurred prior to on a it's just prior to 15th Jan. So there was a dosing date on 1st Jan and it went all the way till 13. So all the records, all the exposure records which occurred prior to this adverse event start date are appearing here for us now. And from this, so we can all we need to do is fetch the latest date available and then use that value for our required final variable. So I am sorting the records based on use subj ID, AE sequence, and then date value, which is our exposure date, which means when we sort the date values in ascending manner, the earliest date comes on top and the latest date comes at the end. So if we pick the last record for each use subj ID and AEC combination, that gives us the required result. So let us go to the final ADAE03. So here if we see, we have the latest exposure date on our latest exposure date prior to the adverse event start date as appearing for us. So prior to the 15th Jan adverse event start date, the exposure date was on 13th Jan, so we got it here. And then for prior to 2nd Feb, the exposure was started on 1st Feb, so we pulled that. And for prior to 15th Feb, so it was on 13th Feb, so we got it. And for 1003, why do we not have a date here? So if we go back and then see the ADAE, so it's 5th March. So if we see exposure, so the exposure started on the same day of 5th March. So we are looking for something before 5th March. So we do not have any record in exposure with a date value lying before 5th March. So that's why we have this value as missing. So this is how you can apply the logic to derive the last dosing date before an adverse event start date. Thank you for watching and keep learning.